Hello everyone, I'm Veekshith Joyson Ammanna, an intern at CyberSapiens. Today we will discuss brute force attack detection using Splunk. The contents are as follows. We will cover the attack basics and the defense strategy. We'll show how to set up detection in Splunk, then we'll finish with the live demo. Introduction to brute force attacks. A brute force attack is simple. It uses automated software to guess credentials. The main goal is clear. Gain unauthorized access to any system. Attackers target any login page. This includes web pages, SSH, FTP servers, and remote desktop access. Why brute force happens? Why are these attacks successful? Because of easy mistakes. People use weak or reused passwords. Systems have no account logout policies. Login pages are often publicly exposed on the internet, and there is lack of monitoring or alerting when the attack is happening. Types of brute force attacks. Simple brute force tries every possible combination. Dictionary attack uses a list of common passwords. Credential stuffing uses passwords stolen from other data breaches. Hybrid attacks mix dictionary words with numbers. Lab setup and tools. Here is the lab setup for the demo. The attacker is Kali Linux using Hydra tool. The victim is a vulnerable server and Splunk monitors the Apache logs. You will see sample Hydra command in action during the demo. Configuring detection in Splunk. Detection starts with data. We must ingest the Apache access logs into Splunk. We use SPL to find suspicious activity. A single successful login after many failures is a critical pattern we detect. Live monitoring and dashboard. In real time, the Splunk dashboard shows these key indicators. This helps the analyst respond. We use the attack source IP and the targeted username. The HTTP status code are monitored closely. A spike in 302 success triggers a critical alert. Best practices for defense. First, strong password policies. Ensure complexity and regular rotation. Second, account lockout threshold. This is critical to auto-lock the account. Third, enable MFA. This adds an extra layer of authentication. Fourth, rate limiting. This restricts how often requests can be submitted. Fifth, real-time SIEM alerting. We monitor logs for immediate alerts. Finally, session timeout controls. This automatically terminates inactive user session for security. Let's head to the demo. Here is the DVWA login page hosted on the Metasploitable 2 machine. DVWA is a purposefully vulnerable web application used for practice. This login form represents a real website login, but with weak security. This is the target in which I will perform a brute force attack on. To simulate an attacker, I'm using Hydra from my Kali Linux machine. Hydra automates rapid login items using a word list. Here, -l admin equals to username, -p rocky.txt equals to password list. Target is DVWA login page. Hydra performs multiple attempts per second. See it. Here, Hydra successfully found the correct password for the admin user. This confirms the brute force attack worked. Login equals to admin, password is password. All these login attempts are recorded in the Apache access log. I uploaded the Apache access log into Splunk for analysis under an index named brute force. Splunk immediately identifies all requests made by Hydra during that brute force attack. These are all the normal login page responses with status 200. During a brute force attack, you will see many repeated 200 responses in a very short time. A 302 redirect indicates a successful login. This shows exactly when the brute force attack succeeded. Right now, Splunk is showing the raw time and count output. I'll now show the visual representation. Here you can clearly see the spike in the login attempts. This confirms brute force activity. This panel shows the status code distribution, giving a quick overview of successful versus failed attempts. That concludes my presentation. Thank you.